Hey everybody, Marcus here. In this video, I wanted to put together a simple career strategy for those MGTOW who would like to get into software development. Now, this will not be a video teaching programming. It will be a video inducting you into the world of professional software development. It is my hope that this video will serve to give the breadth needed to any aspiring developer in order to structure a learning plan for themselves in anticipation of entering the industry. First, let me give you a little bit of background about myself so you can feel confident in the soundness of the advice in this video. Now, I have been working professionally as a developer for, about 13 years. Preceding this, I have been writing code and generally screwing around with computers since the age of 11 or so, starting in about 1993. Though I did not start writing code till around the age of 16, the early 90s were a great training ground as computers were generally unforgiving back then. Now, I hold a degree in computer science. I've worked for about a dozen different companies in industries such as medical, financial, entertainment, telecommunications, research and development, social media, and gaming. I've held positions from, the generic title of developer to director, while under the employment of others, and I played CEO entrepreneur for 3 years with a staff of 5. Now, the largest software house I worked for was Microsoft. I've been a hiring manager in several roles and wielded budgets in excess of 7 figures. So this should give you a bit of a breakdown of where I'm coming from. Overall, I have run, the whole gamut that this industry has to offer with very few exceptions. I learned a great deal in my time in the industry. A lot of the lessons I learned are kind of counterintuitive and may come as a surprise to many of you. First, I will cover a number of lessons I learned about this field, and later I will give a description of how roles are arranged within the field. Finally, I will present a specific end goal that should guarantee universal employability across all industries if pursued fully. The journey from 0 to 6 figures, I estimate, would take someone around 6 years, where the first year is assumed to be completely devoted to self-study. Okay, here are the most important lessons I learned. Firstly, in the software development sphere, you start at the top and work your way down. This means that the best role you will have is going to be at the very bottom of the management hierarchy. Every promotion you get, from developer to team lead or to project manager or to development manager to director or whatever the procession seems to be in the company you're looking at, is a step down in disguise. Now, this may seem counterintuitive, but it is a hard lesson I learned by climbing the ladder. Now, let me try to explain how this works. You see, as a ground-thumping software developer, you spend all your time in code. This means your day-to-day job hones a skill set that is universally valued in virtually all industries, for all projects, in all countries. Every promotion you get begins to narrow down your options, as every promotion slowly puts you further and further away from the code. In addition to this, every promotion you get entrenches you further into the politics of both the particular industry as well as the particular organization, which in turn reduces the transferability of your knowledge to a new organization or industry. Now, you may be asking yourself, won't I get more money if I get promoted? Well, the answer is almost always no. Let's see how this works. Firstly, you need to look at software developers as having a rough progression of titles. You start out as a junior developer, then move on to the title of developer, and then to senior developer. From here, you may hold specialized titles such as software architect, user experience developer, or any number of other specializations. But these title progressions are not promotions in the sense of authority. A senior developer's day-to-day job is not fundamentally different from that of a junior developer. No matter which of these titles you hold, you are still fundamentally writing code and doing little else. Now, this is the bottom of the management hierarchy, as none of these titles involve managing people or spending too much time on non-programming activities. The progression in these titles typically only results in a pay raise, but no responsibility changes. Now, let us directly explore why getting a promotion out of this bottom tier will not usually lead to a pay raise. A senior developer, though still in the bottom of the management hierarchy, can command salaries close to $200,000 at the top limit, while salaries of $120K are quite common in large software houses, and a salary of $70 to $90K is quite common in the smaller software houses. Now, team leads are drawn from the pool of senior developers. However, their salaries will be commensurate with their experience. This means that a senior developer who has been working for 10 years will be making, say, 120K, but need not be a team lead. A senior developer of 5 years might be promoted to team lead, but because of his relative lower experience, he will only be earning 70 or 80K. So, though the team lead has some authority over a senior developer, the senior developer of 10 years experience can in fact be commanding a salary 50% higher than his boss. This difference in salaries grows even larger between project managers and developers. There are tons more project managers available in the industry than there is demand. This brings down their salaries substantially compared to senior developers. Where our senior developer of 10 years experience had a salary of 120K, the project manager might be on 40 or 50K. This difference in salaries tends to start closing at the director level though. Directors tend to make similar money to the most senior developers. Now, it may sound absurd, but trust me, I've been on both sides. Now, let us compare the role of the director versus the role of a senior developer. The senior developer continues to write code day in and day out. He is not bothered by office politics, nor is he responsible in ensuring that the project is on schedule or on budget. The senior developer can be fired or quit with little to no concern that he will find a job of comparable money almost immediately, as the demand for senior developers far outstrips the supply. Of course, this is assuming he is located in a city and not some backwood town. Now, this is a nice, stress-free, high-paying, politics-free existence that the senior developer enjoys. The same cannot be said about the director who is making equivalent money. The director usually has to oversee anywhere from 30 to 60 people. He needs to worry about budgets, reporting up to even more senior managers, and dealing with management politics. He spends a lot of time writing emails, creating reports, and facilitating communication. If he gets fired, he will have a hard time finding a role at the same level as there's not a large demand for directors. His skill set is only partially transferable, as a lot of the effectiveness of a director is contingent on his experience in a given industry, market, and organization size. This means that an IT director in a financial institution will not be as effective in a gaming company, whereas a developer has fewer issues with such an industry shift. Our director is usually working many more hours than the senior developer, as there are 30 to 60 people coming to him with one problem or another. In essence, the director has a lot of responsibility, more stress, and extra hours of work for the same money as a senior developer. So, in this way, in the software industry, you really start at the top and work your way down. It takes an average of 5 years to gain the rank of senior developer and command these 120K salaries. Now, it will probably take you 10 to 15 years to become a director. But there is yet another damning blow against attempts to move up the management ranks, and this is contracting. Now, contractor software developers command ludicrous day rates. I mean, in London, you can get rates as high as £1,200 per day as a senior developer. Let that sink in. Now, it is almost impossible to find management positions if you wish to be a contractor. The end game of any developer is contracting. Now, you might be thinking to yourself that the life of a contractor is much less stable than that of a permanent employee. Well, this too is almost always false. This is the second of the counterintuitive lessons I learned in my career. You see, the explanation for this is concealed in how corporations track contractors within their financial projections. A contractor is an employee that can be let go at almost any point. This puts them in a rubric outside of future projections and cost. A full-time employee, on the other hand, is counted in future projections and cost. Full-time employees are also a lot harder to fire. Now, what I've seen in the industry is as follows. When financially difficult times hit the software industry, corporations need to make cuts. Now, because permanent employees are generally difficult to fire, you get a lot of dead weight staff who have grown complacent over the years but cannot be easily let go. I have seen corporations use financially difficult times as an opportunity to cut dead weight in permanent employees first. When Microsoft was downsizing 5,000 people back in 2008, I was a contractor in their employ. Almost all the 5,000 layoffs were permanent staff. The general disposability of contractors is also a strength of contracting. As software companies have as core business software development, they will always need developers. In uncertain times, it is wise to keep disposable staff doing the work that you can get rid of, at a moment's notice, than to keep permanent staff that are harder to get rid of. Now, this may not always play itself out in the way I describe, but from what I have seen and experienced firsthand, contracting is generally the safer bet for a software developer. There are many other reasons for this. Firstly, are the reasons I have just mentioned: security during downsizing. Secondly, contractors earn substantially more than permanent employees. You can earn a full year's salary in, say, 3 to 6 months of work, whereas a full-time employee would need to spend 12 months. Now, you might be asking yourself, if this is true, why would companies hire contractors over permanent staff? Well, one reason is that contractors do not cost much more than a permanent staff member, even though they earn a lot more. You see, permanent staff leverage all sorts of benefits that the corporation pays for in addition to paid leave, and so forth. However, many of these benefit packages are aimed at families. So, company paid for health insurance may be a meaningful benefit if you have a wife and 3 kids, but as a single man, you are better off taking the cash equivalent of that and pay for your own health care. Also, many benefits that companies give are contingent on life choices. For example, I know one bank that offered to pay your monthly mortgage and car loan payments as a benefit. Of course, what this bank does is simply take on your loans, spreads these loans out to their maximum durations, and makes the minimum payments. This may be a valuable benefit to someone who owns an expensive house and an expensive car, but it is a meaningless benefit to someone who does not. A contractor, once again, gets the cash equivalent, whereas a permanent employee would not if he did not own a house or car. When you compare the cost to a company for a permanent employee and a contractor, the numbers look pretty similar. However, the contractor gets his benefits in cash as opposed to options you may never leverage. Thirdly, recruitment agencies make massive profits off contractors. A headhunter will take a one-time fee for placing a permanent employee, but the agency takes a monthly cut for a contractor. Also, the margin the agency takes is a percentage of the day rate of the contractor, which encourages the agency to fight for the highest possible rates on behalf of the contractor. Also note that this margin is not taken from the contractor's day rate, but is a fee charged to the employing company in addition to the contractor's day rate. The typical agent percentage is 7%. If they place a contractor at a $500 day rate and the contractor works 20 days a month, then the agency will take $700 for each month the contractor is employed with that company, while the contractor will take home $10,000. Fourthly, because contracts tend to roll on a 3 to 6 month basis, the contractor always has his hand on the pulse of the job market. This means that he is always in touch with the movers and shakers on the recruitment agency front, which also means he is always aware where new roles are popping up, how much they pay, and what direction the technological demands of the market are shifting in. This has an effect of giving you a sense of situational awareness in the market at all times. Personally, I get recruitment emails daily and usually 2 to 3 calls a week each and every week from recruiters trying to poach me. Finally, contractors do their taxes differently than permanent staff. All income paid to a permanent staff member is subject to income tax, as it is paid to the employee as income. This is not the case for a contractor. A contractor owns their own corporation. This corporation invoices monthly the employing company for the labor of the contractor. How much, how often, and in what way the contractor then decides to pay himself from the monies held by his corporation is his own business. Also, a contractor benefits from things like director expenses, and a whole lot of other tax-free ways of accessing the corporation's money without it counting as salary. Or, he may choose to not pay himself at all. He may choose to pay corporation tax on any profits his corporation earns, and then over several years pay himself a salary under the taxable yearly income limit to get that money out of the corporation. This is an excellent way to save for retirement. So, where a permanent employee may earn $100,000 in a year and pay out 40% in taxes, a contractor who invoices $100,000 a year may choose to only pay himself a salary of, say, $30,000 and stays at the lowest income tax rate. Then claim $20,000 in tax-free director expenses, for things like his apartment, gas bill, electricity bill, travel expenses, and so on, while leaving the remainder of the money in the corporation to invest with, and only pay corporation tax on it. Of course, depending on which country you live in, corporation tax may be large, but for me, corporation tax is 12%. Once corporation tax is paid, that money can sit in the company indefinitely, tax-free. You can basically keep hoarding money in your company this way until you choose to retire. Then withdraw that money as income over many years, paying little to no income tax. Of course, while this money is in the corporation, it is properly invested and not sitting in a worthless savings account. Now, let us move on to another lesson I learned over the years. You do not need to have a university degree or any certifications to gain employment as a software developer. This is much more true today than it might have been a decade ago, as there are many exemplars of success stories of people who never went to university in this field. Also, you will find that many hiring managers themselves may not hold a university degree, and as such see little reason to hold prospective hires to that standard. One of the best managers I ever had was in Microsoft. The man only has a high school diploma, is in his mid-30s, and is a regional director. He learned to code on his own and had no problem breaking into the industry because he was good at what he did. Now, I have served as a hiring manager myself, and I have had countless friends in the industry who have been or currently are hiring managers. The primary point of interest of any resume is the technologies that a candidate has experience with and years of experience in the industry. The most valuable quality, however, is entrepreneurial experience. What a hiring manager is looking for in a candidate is someone who has courage in code and can take initiative. Now, this may seem like a strange thing, but you find that there are a lot of cowardly developers in this industry. Now, a cowardly developer is a developer who is afraid to make wide sweeping system changes in order to improve the codebase as a whole. A cowardly developer will stick to sections of an application they understand and hardly ever deviate from their comfort zone. The analogy to this is someone who is afraid to leave the city that they grew up in. But first, let us talk about what getting a degree in computer science looks like before we dive into any details of the job interview process. Now, it is important to understand that a degree in computer science is not a degree in learning how to be a software developer. It is an overview of the entirety of the field of computer science. This means that you will spend time with mathematics. You need to learn mathematics in order to grasp concepts that you would need if you want to build, say, your own processor or programming language. You will spend time composing pseudocode algorithms, solving highly academic contrived problems that are, well, only ever encountered in academia or in the highest echelons in the research and development departments of very large corporations. In a word, of a 4-year degree, you will spend no more than 1 year on writing actual code. In my program, there were 2 modules which dealt with programming directly. One was based on the C programming language, which is a procedural language, and then the follow-up was a single 4-month module on programming using Java, which is an object-oriented language. There were a total of 32 courses I needed to take in order to graduate with a degree in computer science. Of those 32 courses, only 18 were compulsory. Of those 18, 4 were pure mathematics, calculus, algebra and geometry, set theory, and finally graph theory. Of the remaining 14 courses, 4 were related to hardware, namely construction of things like adders via logic gates, how network hardware like routers work, and various other material related to the physical construction of various computer parts from the most basic material. I am sure there is an overlap with electrical engineering in these courses. Now, of the remaining 10, One course was a basic computer use course. So, how you turn a computer on, how you open Notepad, save a file, and so on. Of the 9, we said that 2 were directly related to programming. Of the 7 remaining, 1 module was about databases, 2 on development methodologies, which dealt with theories about how teams come together to organize themselves on a project. The remaining 4 are highly detailed, mostly mathematically oriented courses discussing certain concepts used in software development, such as file structures, data structures, algorithm design, and so forth. Now, it might seem like there are really only around 7 or 8 courses which are directly relevant to software development. Now, this is a half-truth. But even if it was completely true, this would mean that there's only one full school year in a computer science degree that actually deals with software development. However, the full truth is much more interesting. You see, other than the 2 modules that deal directly with programming, the remaining courses are mostly theoretical. However, they are theoretical in a way that is not very relevant to the day-to-day work that a software developer does. Now, let me give you some examples. The courses that dealt with how teams come together in organizing themselves to build software taught models that are not actually used in industry in a majority of places. So, though in theory you are learning something you might use, the odds are stacked overwhelmingly against you that you will find yourself in a company that actually uses these methodologies. Now, you may be thinking to yourself that the reason for this is simply that the university is behind industry, as far as practices are concerned. Now, this is only partially correct. Yes, university courses sometimes are behind the times, but the complete answer is that virtually every team in every company has grown a methodology of its own that best fits the political landscape of the company, the skill set of the team, the nature of the product, and the size of the team. This means that in school, you merely learn the concept that teams organize themselves around methodologies, but you will never be able to learn the exact details of a methodology of a team until you start working in that team. Also, when you are learning these methodologies in theory, their application looks almost nothing like what you imagine it to look like. Also, by the time you hit the industry, the details of the module have long escaped your mind. Now, what about courses in data structures? Well, these 2 are only half useful. The level of detail you learn about things like linked lists is so fine that it loses all but the highest level meaning in the industry as opposed to academia. Now, let me give you a concrete example. Imagine that you need to store a list of names in some data structure. You can choose to use an array, a linked list, or say a hash table. Now, let us assume that the array has a performance rating of 1, the linked list of 10, and the hash table of 100. Well, in this example, it would appear that the hash table is 100 times slower than the array. So you might think to yourself that you have written much better code by using the array as opposed to the hash table. And this might be true. However, in a real-life scenario, this may mean that a user either needs to wait 1/1000th of a second or 1/10th of a second for an operation to complete. As neither are temporally perceptible by a human being, your selection of an array over the hash table is effectively meaningless to the user experience. Now, this was a contrived example, but it serves to illustrate the point that though intimate knowledge of data structures may be useful, it has such diminishing returns that it almost becomes meaningless except in insanely high volume operations, which is not as common as you might imagine. Also, these courses have an interesting way of forging your thinking about writing code that is counterintuitive to practical application. Now, let me ask a simple question that almost every junior developer gets wrong. What is a software developer meant to do? Now, the most common answer is, well, a software developer is simply meant to write code. Now, this answer is wrong. A software developer is meant to solve business problems. Well, you might be saying to yourself, but Marcus, that's just wordplay. Of course a software developer is meant to solve business problems, but he will do so by writing code. My response to this is that once again you are wrong. Writing code is not the answer in a very large number of cases. This is the trap that juniors fall into because in university you learn to pass courses by solving academic problems and not business problems. The correct approach is to first find an existing product that you can configure to meet your business needs. This is almost always the cheapest and fastest resolution to most business problems. If no such product exists and the company decides to build their own, then the next solution is to look for an existing product that mostly meets your business needs, but also has an application programming interface that allows you to customize it adequately through writing code. If this does not exist, then you need to plan out your requirements and then look for individual existing components, either proprietary or open source, that you then merely connect together through either configuration or code. Now, this is the level at which most homegrown solutions will end up. If you need functionality that simply no one has ever written before or written badly, then and only then do you write the code to perform the function yourself. You see, one of the ex-CTOs of Microsoft, now I don't remember which one anymore, said that the difference in productivity between a top-end software developer and an average software developer is not a factor of 2 or 5 or 10. The difference in productivity is a difference of 10,000 times. The reason for this is that the best developers in the world write the least amount of code. They have this enormous breadth of awareness of various existing components that they can simply connect together to solve business problems in a blink of an eye. It's the junior developers who are writing the most code. The most experienced developers are writing code, but that code is mostly used to connect existing components written by others, like playing with Lego. I mean, just look at WordPress. WordPress is nothing but a very configurable application for a non-technical end user. However, it also lends itself to customization through writing plugins. A senior developer would much rather take WordPress and extend it than even considering of rolling their own blogging platform. However, many university-educated juniors are so detail-oriented, trained on a curriculum of academic rigor, that they can only see the faults in WordPress, and in their arrogance would come to believe they can build something better. This is a common problem with developers. They miss the point of what they set out to achieve. Okay, now I think we can see why getting a degree in computer science is not needed to become a software developer. The breadth of topics covered in such a degree covers areas you will never touch as a software developer. In addition to this, many activities and tools you will use in industry are never taught in a computer science degree. The good news is that 90% of all software developer roles will never demand any of this specialized knowledge. There's a whole hidden world of software applications that exist for internal use in organizations that are never meant for public consumption and that you guys will never ever see unless you work in the field. Now, certifications in the various software development qualifications have a limited benefit in terms of securing employment, though they are not completely useless. Now, if you want to teach yourself to be a developer, then there's only one attitude you should take to certifications. Certifications are guides for basic competencies you should possess in order to not sound ignorant when discussing the subject at hand. This means the following. Look at a certification, get the syllabus, go through the syllabus, but don't bother paying to get the actual certification by taking the exam. Use the certification material to help create a roadmap for your own education, but little else. There are many certifications that truly mean nothing. I mean, they only communicate to the hiring manager a form of initiative, but do not themselves stand as placeholders in guaranteeing the candidate knows anything about software development. Like I said, it's mostly down to years of experience and technologies known. Now, let me give you some insights into what goes through the mind of a hiring manager, both when sifting through resumes and then during the interview. This should be useful in evaluating the role that education and certificates have in the hiring process. If the hiring manager is himself not technical, he most likely have passed on the resume to the team lead for whose team he is hiring new developers for. If the non-technical hiring manager is not doing this, odds are good he is not a very good manager, and you don't want to work for that team anyways. However, those sorts of managers will usually look for things that look objectively good. University degree, number of companies a candidate has worked at, and the years spent at each company. Now, the reason that a hiring manager is looking at the years spent at any given company is to wager the general loyalty of the candidate. He will look for breaks in the career of the developer and will also look for keywords such as technologies used. Now, I don't want to spend any more time talking about the non-technical hiring manager, because that is not going to be most of the scenarios you encounter. The most common scenario is that the ultimate decision maker will most likely be technical, or the opinion of a technical team member will hold overwhelming sway on the non-technical hiring manager's decision. Now, a technical hiring manager looks at a resume in the following way. First, he asks himself, what level of developer do I want? Now, this is very important, as said earlier. 2 juniors is not equivalent to 1 senior developer. So, if you are just starting out your career, you do not have a snowball's chance in hell of getting a job with a team that needs senior staff. Let us assume that the hiring manager is looking to hire junior developers. First, he thinks to himself, do we have a senior developer on the team who will be able to assist the junior developer in their work? If there's a shortage of senior developers who would have the time to mentor a junior, the hiring manager will not hire a junior. Let us say there is a senior developer who would have the time. The next question the manager asks himself is the following. Does the junior developer have a focus on the core platform used by the company? Now, this is very important to note. Each company usually specializes in a single platform. It is only the very large corporations that may have teams that use a diversity of platforms. Now, my advice is simple on this front. Specialize in one platform and do not attempt to diversify, because you will most likely turn out mediocre in both. However, this will be clarified later in the video. The good news is that most organizations tend to specialize in either the .NET stack or the Java stack. Now, this is good news because it means you don't have to worry too much about what to choose from. But anyways, if the junior developer's resume indicates that he specializes in the core platform of the organization, he is considered further. The next question the hiring manager asks himself is if the junior developer seems to be a full stack developer or specialized to a specific tier. Now, this will become clearer later on, but full stack developers are always favored over specialists in small to medium teams. In fact, other than some very large corporations with very specific needs, full stack developers win hands down every time. The next question is a compound question. How much cash is a developer asking for in comparison to his years of experience? Now, what is important to know is that a junior developer ranges from 0 to 2 years experience, so it's not like you would be competing with someone with a decade of experience. The price difference between such developers obviously is very large. A junior with 1 year experience is almost always looked up more favorably than a developer with no years experience. But a junior with 1 year is not really worse off than a junior with 2 years. The jump from 0 to 1 year is large, but usually a developer with 1 or 2 years experience is not that radically different. Now, if you are asking around $25,000 to $30,000 for your first software job, you are in the correct range. I've seen juniors ask for as much as $45,000 and pass them by because there's little reason to blow an extra $15,000 on a junior when you can get a second junior for a mere $15,000 in addition to the asking price of $45,000. And just so you know, Microsoft pays entry-level juniors $33,000 per year. Okay, once the experience to price ratio is right and all previous considerations have been met, the junior is asked to come in for an interview. Now, getting an interview is relatively easy with the right keywords on your resume, but getting through the interview is a different beast altogether. Now, there is a curious phenomenon that happens when a senior developer interviews a junior developer. A senior developer usually sees himself in the junior developer, to some level. He was there at one point in his career, and he wants the junior developer to get the job. If he likes the junior developer personally, of course. Now, you need to keep in mind that the technical hiring manager will most likely be working on the same team as the junior developer he is hiring for. This means he is looking at a lot of non-technical qualities about the junior. Developers work in teams. One bad apple can poison and destroy a team, so personality is as important as skill. The senior developer most likely will go quite easy on the junior in terms of the interview, unless, well, he's a power-hungry egomaniac, in which case you don't need to concern yourself about getting that job. Now, a hiring manager will most likely ask general, open-ended questions. When he does this, the hiring manager is looking to see how the thought process of the candidate looks like. These open-ended questions seem the easiest to answer, but are in fact the most revealing. The reason for this is that the hiring manager will not only hear what the candidate says, but also what the candidate does not mention. The candidate will clearly not be in a position to mention things he has no experience with, and if it becomes the case that the candidate seems to be omitting many important aspects of a general question, the interviewer will think less of the candidate. Specific technical questions will also be thrown in, but they should be relatively benign. Now, these questions usually probe the depth of a particular subject. The purpose of these questions is not so much to catch you up in a wrong answer, but to wager how much mentoring might be needed by a senior developer. Of course, if you consistently get all the technical questions wrong, then you will be looked down upon. What many junior candidates don't realize that would help them immensely get through interviews is that saying that you would look it up on Google is a valid answer if you can elaborate on how you would conduct the search. The point is not necessarily that you immediately know the answer, but that you know how to relatively easily find the answer. In interviews I conducted, I would put a laptop in front of a candidate and tell them they can use it as a resource to answer questions if they wish. Now, some answers people would look up, but when they did use Google, I was looking to see how long it takes them. Also, I found that letting candidates look up answers took a lot of the edge off, which removed the fog that interview stress can impose on your mind. Outside of the questions themselves, the hiring manager will definitely be looking for arrogance in the candidate, general likability, and some sort of backstory that signifies genuine interest in software development. Though a senior can say that he does it for the money, such a jaded answer is very unbecoming of a junior developer because self-motivation is absolutely critical for someone just starting out. Now, if the hiring manager likes you and is satisfied with your answers, he may call you in for a second interview, he may give you a job offer, or he may issue a programming test. Now, programming tests can take many forms, but what they usually look like is one or two problems you are asked to solve in code and send your results on later. This test is usually done on your own time at home. Now, programming tests are, well, a pain in the ass. Some can be very demanding in terms of complexity, while others may be straightforward, and yet others may be open-ended, such as, send me code you would be proud to put into production. The program can do whatever you like, but it needs to be written to the best of your ability. Now, if you are ever asked to do a programming test, do it the same day you get it, or by the end of the following day. You will not usually be given a deadline for these tests, though. This is part of the test. I have known hiring managers that have issued very challenging tests that took in excess of 12 hours to complete, but never actually looked at the results. The reason the test was issued was to see if I actually wanted the job enough to jump through that hoop. If you could follow instructions. There was no other purpose for that hiring manager in issuing that test. Because the test was so complicated, some candidates self-selectively excluded themselves simply by not sending back their work. Such a self-selecting filter would speak to the candidate's skill, or to their confidence. Now, do not assume a reason why you may be asked to do a programming test. What the hiring manager was, maybe looking for may be drastically different between hiring managers and then what you suspect the reason to be. Now, I have issued programming tests myself. The ones I issued were always open-ended. I asked that the candidates simply send me code they're proud of, whether it was something they wrote before or something specifically for this test. My objective was to see what the candidate deemed pride-worthy, as this told me their level of understanding of not only software development, but of writing impersonal, standardized code. These are things the candidate could never fake, any more so than you can fake playing the piano. Okay, Having covered the mentality of a hiring manager when filtering resumes and when conducting interviews, let us now position software development certificates. For a junior developer, certificates only show initiative but say nothing of the skill set of the candidate. That is revealed in the interview. I would be more readily inclined to call in a junior for an interview with certificates if he had no work experience, but those certificates would not hold as much weight as a single year of industry experience, all else being equal. Now, throughout my entire career, two things held true. I was never asked to show my university degree, and I was never asked for references. I had one Microsoft certificate that I did a decade ago that I was also never asked about. My advice is this: go through the certification course on your own for cheap as a self-study guide. However, don't worry yourself too much about doing the actual exams. Besides, certifications tend to expire anyways, so they can only be of any use in getting your first job. Now, let me break down for you how to hit that sweet spot of universal employability as a software developer. To do this, I need to explain to you the basic three-tier architecture of most software products. Now, this architecture seems to have formed the basis from which you have the various software roles spring from. The three tiers are as follows: front end or UI, middle tier, and back end. Now, these are generic classifications that tend to cover a very wide variety of technologies and roles, but these tiers create groupings under which you can organize your career as a software developer. Let us go through each of these tiers and briefly describe what fits where. The top tier is the front end or UI. In this tier, you have developers who are creating the user experience of a program. They determine what screens will exist and what the visuals will look like, and so forth. When developing a website, the front end also encapsulates everything that happens in a user's browser. The middle tier, on the other hand, is usually pure code that has no visual aspect. This is usually where business problems are solved through the Lego-style assembly of existing components or custom code. The back end is concerned with databases and the storage of data in general. We can also describe the three tiers in the following way. The front end is what the program looks like and how a user interacts with it. The middle tier is what solves the business case and responds to user activity in the front end. And the back end, then, is where information is stored, like orders placed on Amazon or your Facebook profile. Now, there is a diversity of types of computer programs that a software developer may be tasked in creating. Since my objective is to maximize on employability, we will talk only about web applications. Web applications are nothing more than complicated websites. Websites like Facebook, Google, YouTube, Amazon, eBay, and so on. These are all web applications. I won't be discussing mobile application development, such as app development for the iPhone or iPad. I will not be talking about programs you install, like Photoshop, Audacity, or video games. The reason I omit these types of programs is that compared to web applications, these are all niche products. In order to maximize your employability, we need to aim at the most boring, but most common forms of software products that employers are developing: web applications. Also, to those developers watching this video and shaking their heads at my breakdown, this video is not intended as a choose-your-own-adventure video. This video is a roadmap to guaranteed employment. Now, what unites these three tiers together into a single product? Well, a development platform. There are two platforms that cover a very large portion of the boring web application jobs. These are Java, the open source platform by Oracle, and .NET, the open source platform by Microsoft. Now, I can already hear software truthers out there screaming into their monitors that you can write web applications on Ruby or PHP, and other technologies. To those aspiring to be developers, avoid these truthers. Java and .NET are tried and true platforms that are the bedrock of the banking systems of the world and the bedrock of virtually all large businesses. There are thousands of technologies out there that get fanatical fanboys. Now, these technologies fade into oblivion most of the time. I call these technologies hipster tech. Technologies that are cool because no one uses them. We are concerned with employability and not nerd cred. Java and .NET are the meat and potatoes of the software development world in this case. The simple test for this is to do a job search based on the keyword of .NET or Java. Now, as an aspiring universally employable developer, you will need to specialize in one of these platforms to get to the top tier of developers in it. I have taken the .NET route, and so the rest of this video will talk in context of .NET and mostly Microsoft technologies. I recommend .NET for everyone, as well. It's an amazing and rich platform which has a large community supporting it and a great deal of open source components, as well as tons of guides, articles, and code samples. Okay, now that we've settled on .NET, let us rework our three-tier architecture to reflect the appropriate technologies in each tier. As we can see, I have contained each tier to 8 line items. This may seem like a very long list, but once you start engaging yourself in the subject matter, you quickly figure out where each of these technologies fits in. Now, to get a simple website in place, you only need to figure out 2 technologies from the front-end tier. You need to get a very basic understanding of HTML5 and CSS. To author your simple web page, you don't need any special tools. Open Notepad and type your HTML and CSS, then save the file with a .html extension. When you open your HTML file in a web browser, your page will be displayed. Now, if you were to master HTML5 and CSS alone, you would have a minimum skill set to get a job as a web designer. However, you would not be employable as a software developer. In order to be considered a junior level software developer, you would at minimum need to have some level of competence in all the technologies highlighted in red. Now, let us rework our 3 tiers in terms of general job titles. Though not every entry is a formal job title, it goes to show you what you can expect from your career if you specialize in any given tier. If you specialize in some combination of the technologies mentioned in the front end, you will have the skill sets to get a role as a web designer or a UX designer. If you specialize in nothing but the middle tier technologies, then you will be a software developer, but a very limited developer. If you specialize only in back-end technologies, you can become a database administrator or database analyst. If you specialize in a combination of technologies from the front end and middle tier, you will become a web developer. However, if you learn technologies from all 3 tiers, you become what is known as a full-stack developer. A full-stack developer is referred to as such because he knows his way around all aspects of the relative platform. In our case, a full-stack .NET developer. The full-stack developer is universally employable. Full-stack developer is not so much a job title as it is a descriptive term of the utility and flexibility of a developer. Software architects, principal developers, and team leads are always full-stack developers. Most full-stack developers hold the title of software developer. Now, at first, this list of technologies may seem very long and very intimidating, but you are surely projecting some assumptions into the situation. You see, a full-stack developer is not a master of every technology. He is usually a master at only a few of these technologies and only mid-range at the rest. The value in a full-stack developer is not in a breadth of mastery, but in his ability to correctly identify the technologies to most efficiently and clearly solve a business problem. In fact, only full-stack developers are capable of architecting anything approaching a complex application with any degree of confidence that the project will succeed. They are the only ones who can conceptualize the entire end-to-end flow of a web application. Your goal is to become a full-stack developer without getting promoted out of that bottom tier. Now, previously, we have also mentioned that contractors earn the highest rates of all software developers. So when we combine the two, your mission is to become a full-stack developer who is employed as a contractor. Now, this combination puts you into one of the best careers that exists in this day and age. It pays ridiculously high. It makes you employable by almost every software company in every country in the world. And it is a skill set that you can use to start your own company without the need for any startup capital or staff. Now, the next question becomes, how do I get from aspiring full-stack .NET developer contractor to actual full-stack .NET developer contractor? Well, it only takes commitment and time, and virtually no money. The first thing you need to learn is your first programming language. As we are focusing on the .NET stack, the language we will be learning is C#. This is what you do. Go and download Visual Studio 2015 Express for Web and buy yourself a copy of C# 6.0 and the .NET 4.6 Framework 7th edition by Andrew Troelsen and Headfirst C#. Now, you can write C# code in Notepad if you like, but you can make your life a lot easier if you use Visual Studio. Now, Visual Studio is like a developer's version of Notepad. Remember, code is just text. The books I recommended work well in synergy. The Headfirst book will get you from 0 to 60 as far as C# and Visual Studio are concerned, while Troelsen's book will take you from 60 to warp speed. It won't be quick, but if you keep at it for 1 year, you will bring yourself up to the junior level, and 5 years after that, you'll be commanding a 6-figure salary if you stick to it and are not afraid to ask for such a salary. You have no idea how many guys I met were afraid to actually ask for what they were worth. Now, the key is to write code. The more you write, the more understanding you will gain of what the whole field involves. Eventually, you will get to the point where you can see there is no reason to write as much code anymore and start to seek out existing solutions on the internet that you can simply connect together. You may find that you get a great idea and put on an application of your own design, that makes you rich. Start your own startup. Who knows what will happen? Now, before I close off this video, I wanted to raise one more interesting thing I learned from software development. After being in the industry for 8 years or so, I found a passion for philosophy. When I started reading Plato, I realized that object-oriented programming, the dominant programming paradigm for the last 40 years, is literally Platonic metaphysics. Now, this connection between software development and Platonism became even stronger after I read the Platonic dialogue entitled Timaeus. In the Timaeus, Plato describes his cosmology. He constructs reality out of triangles. Now, all 3D virtual worlds like World of Warcraft are mathematically constructed out of triangles. The performance of video cards is partially measured by how many triangles it can render a second. Now, it was a crazy realization for me that my modern day occupation has its roots in 2,500-year-old philosophy. That kind of makes you think. But for now, I hope that this video was helpful for you in understanding the software industry, setting a clear end goal and finding a starting point. Now it's really just up to you. Download Visual Studio, get the books, start writing code. There's not much more to it than that. Thanks for listening. Go team.